All right, maximums and minimums are literally the highest and the lowest y values on a graph or in a table or in a set of ordered pairs. We are also sometimes interested in whether the outputs of a function are getting larger, which we call increasing, or getting smaller, which we call decreasing as the input increases, okay? As the behavior of the function, right? From left to right, you're looking at it, you're looking at the x values. We want to know, are the y values increasing sometimes? Are they decreasing sometimes? This is part of the behavior of a function. So exercise number 3. Using the same function from last page, answering the following questions. Remember, always read the graph from left to right. This is important. So A, there are 4 distinct portions of this function. For each interval below, state whether the function is increasing or decreasing. Okay. So from x equals -4 to x equals -2. Let's take a look at what that would look like. So -4 is right here. So here is where this function is starting, and we want to go from -4 to -2. So we want to know in this location right here, is the function increasing or decreasing? Well, remember, we're going from left to right, right? So think about if if this was a roller coaster and you were on a roller coaster car, okay, and you were starting on the left-hand side, you would be going up during this portion of the roller coaster, right? So this function is increasing between -4 and -2, right? So increasing is our first option. Okay, then they want to know from -2 to 1. So now we've got from -2 all the way to x equals 1. That's down here, x equals 1. So this yellow portion of the graph is what they're talking about next. And they're asking, are you increasing or are you decreasing? So again, think about it like a roller coaster. If you were on a roller coaster car, this is where the drop would happen, right? You'd be going down. You're going way down. Okay, so decreasing during this stretch. Okay, and then from 1 to 7, okay, so 1 is all the way down here because it's x equals 1, right? To 7 is all the way over here. So what's happening with the y values? What's happening with the outputs? Y values are getting larger, right? We're starting from -4 and -3, -2, -1, 1, 2, 3, 4, 5, 6, and then we're ending up at +7 for the y values. So we started at -4 up to +7. That means we're going up. So again, if this is a roller coaster, you're going up again, right? Up, 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 up for another drop. Okay, so this is increasing. All right, and then the last portion they're looking at, x equals 7 to x equals 10. Okay, so that would be 7 to 10. So that's this little portion right here. And again, we're having another roller coaster drop. So that would be a decreasing portion of the graph. Okay. Okay. It just so happened that this was alternating, increasing, decreasing, increasing, decreasing, but not always the case. Okay. So don't assume that it's just going to alternate like this. Sometimes graphs will start increasing and then increase again and then increase again. Okay. And it all depends on the interval that they're talking about. Okay. All right, so last question on this page. The location where a function changes direction is known as the turning point. So there's another vocab word we need to know. Turning point. It's where the function changes direction. State the coordinates of all the turning points. Okay, all the turning points are any time we turn from increasing to decreasing or decreasing to increasing, right? So the green area was increasing and then it got to the yellow area, which is decreasing. So this point right here was a turning point. Let's label it. This point is -2, 5. So that was our first turning point. Then we got the yellow area that went all the way down, decreasing, and then it hit this turning point here and then went increased, right? So this is 1, -4. I'm just labeling on the graph for now because it'll be real easy to just take these and rewrite them for the answer to B. Okay, increasing all the way till I get to this point and then decreasing again. So this is another turning point, and this is 7, 8. That's the one we got wrong on the last page, right? It was 7, 8, not 8, 8. Okay, so -2, 5 is our first one. Okay, and we're actually going to make this a set because a set of all turning points. Okay, so let's make this in set notation. Let's put our curly brackets. So all the turning points that are included are, what was it again? -2, 5. And the next turning point was 1, -4. And then the last turning point was 7, 8. So there were 3 turning points included in this set of turning points. All right, guys, I'll see you for the last page in the next video.